Hello friends, myself Dr. Girish Kun, Assistant Professor from Mahatma Phule Arts and Commerce College, Panvel. Today we will discuss about the different crystal systems and Bravais lattices. Coming to the crystal systems, as we know, crystal systems can be drawn with the space lattices or three-dimensional space lattices and is defined as the arrangement of imaginary points in the three-dimensional space. Or three-dimensional space lattice we can generate by repeating the translation of a three-dimensional or three translation vectors A, B, C. Crystals generally are classified based on the shape of the unit cell, and all these systems are distinguished from one another by their lattice parameters. So coming to the crystal systems, there are seven crystal systems like a cubic, tetragonal, orthorhombic, rhombohedral, also called as a trigonal, hexagonal, monoclinic, and triclinic. So these seven crystal systems are there. Now the question comes how we can remember these seven crystal systems. So over here I will give you the trick to remember these different seven crystal systems. Okay, so in order to remember this seven crystal system, you can remember this is a short form CTORHMC, which stand for the initial letter of this seven crystal systems and the last letter of the last type of this crystal system. I mean for triclinic it is a C. So for CTORHMC stand for cubic, tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic, and triclinic. So in this way you can remember the seven crystal system, or you can remember them with the this long form also, which is a chief technology officer from Rational Hybrid Monte Carlo. So with this trick you can remember this seven crystal system. Now coming to the details about this seven crystal systems, as I told the trick, the same trick you can remember to draw this seven, or to understand the details of this seven crystal system. Like as already we have talked, these seven crystal systems are classified based on the unit cells, and they are distinguished from one another by their lattice parameter relations. Okay, so first of all, what we can do with the sequence, we can draw the unit cells based on their relations. So first of all, after drawing the unit cell, you can write down the relations, and this relation is also having the some sort of sequence, as we are writing the type of the cells. Like for cubic crystal system, as we know all that all angles are 90 degree and all sides are equal. So cubic contains all the sides or the translation vectors A, B, C are equal, and alpha, beta, gamma are 90 degree. For tetragonal, all angles are again equal, and A equal to B, not equal to C. For orthorhombic, all sides are not equal, means A not equal to B, not equal to C is there, and all angles are equal and 90 degrees. So for first the three cells, all angles are equal and 90 degree, whereas the lattice parameters relation is going to change by the certain sequence. Okay, now coming to the RHMC, rhombohedral, hexagonal, monoclinic, and triclinic, you can see the for rhombohedral all sides are equal, all angles are equal, but angles are apart from the 90 degree. They are not equal to 90 degree. If they are 90 degree, it will be cubic crystal system. Okay, now coming to the hexagonal crystal system, now the relation between the lattice parameters is going to change. So over here in hexagonal, A equal to B but not equal to C, alpha and beta equal and equal to 90 degree, and gamma is having the fixed value 120 degree, and this value is not going to change. A, B, C can be changed, but relation A equal to B will be there but not equal to C, and angles will be constant, alpha equal to beta equal to 90 degree and gamma equal to 120 degree in this crystal system. Okay, now coming to the monoclinic, again the relations is the same as like a hexagonal, but angles are different, like alpha equal to gamma, which are 90 degree both, and beta is not equal to 90 degree. Okay, so this is the relation for monoclinic. When we come to the triclinic, all sides are not equal, means A not equal to B not equal to C, and all angles are not equal to 90 degree and they are unequal. Okay, so A equal to B equal to C, and alpha not equal to beta, not equal to gamma, even they are not having the 90-degree value. So this is about the relation and the shape of the different seven crystal systems. Okay, now coming to the Bravais lattices. Bravais is the scientist who discovered that the 14 types of lattices can be drawn under the seven crystal system. Okay, and only 14 types of unit cells are possible with the different seven crystal system that he first discovered this possibility. Now this space lattice is called as a Bravais lattice, and over here you can see the unit cell has been drawn, and its edges, at the edges different crystallographic axes like x-axis, y-axis and z-axis has been drawn. Over there you can see the unit translation vector, which is named as ABC. After that one can see the interfacial angles alpha, beta, gamma. Okay, over here you can see the one crystal system is there, which is build up, or which is constructed by repeating the unit cell in a three dimension. So one of the block can be considered as a unit cell of this system. Now before going to in the detail of the Bravais lattices, we have to note down the some symbol that generally used to represent the mm, uh, unit cell within the these different types of Bravais lattices. So first one is a primitive lattice, which is represented or symbolized by P letter, and this primitive lattice having the points only at the corners of the unit cell. So if the lattice having the points only at the corners, then it will be primitive lattice, and others are the non-primitive lattice, because for the non-primitive lattices we know the points only will be at the corner as well as apart from the corners. Okay, so first case is the body centered lattice. It is also called if we consider the point, it is called as center of inversion. So I stand for inversion, and body centered lattice having the points at the corner as well as the body center of the unit cell. Then coming to the face center lattice is represented by F, having the points at the corner as well as the face center of the unit cell. Then base centered lattice is represented by capital C letter, and it having the lattice point at the corners as well as at the top and bottom base centers of the unit cell. Okay, now coming to the Bravais lattices, as specified over here in this PPT, the Bravais lattices totally you can measure there are 14. Okay, so with the different crystal system, first three crystal systems has been written in the same sequence: CTO, cubic, tetragonal, orthorhombic. After that it has been write on the monoclinic, because I mean the in the first table you can see the primitive as well as the non-primitive cells are there, whereas for triclinic, rhombohedral and hexagonal, only primitive cells are there and non-primitive cells are absent. Okay, in cubic crystal system the primitive cell is there along with two other non-primitive cells are there. One is the inversion type, and another one is the face centered lattice is there. For tetragonal, primitive and non-primitive unit cell is there. So primitive having only points at the corner, and for tetragonal, one inversion type or body centered lattice is there. For orthorhombic, all types of unit cells are there, primitive and non-primitive. So in a primitive cells having the atoms or points at the corner, uh, apart from that it having the base centered, body centered and face centered lattice. For monoclinic it has a primitive and non-primitive also. So non-primitive is a base centered unit cell. So with this type of unit cell you can draw this different types of Bravais lattices. and their unit cells, and you can write down the relation between the different lattice parameters. So this is about the Bravais lattices. Thank you very much for watching this video.